Hello all, hope you're doing well. So what we're going to be doing here is guided notes and then a little bit of self-guided stuff on the back. And this kind of just gives us some context of the structure of an of atoms. So there's another video that goes along with this, but you're going to have this worksheet. And just follow along filling it in before you hand it in. So we already went over this. The three particles of the atom are the three main parts. These are three bits of the parts. You can think of this as like your organs or what makes up the atom. The three parts are proton, electron, and neutron. And you don't need to draw this part unless you're doing this by hand, because on a computer it's a real pain in the butt. But usually you have two things on the inside, the P, the proton, and the N, the neutron. Those two things kind of hang out together on the inside. That's called the nucleus. And that makes up the vast majority of the bulk of the mass. And then you usually have one guy flying around outside, and that's the electron. It's teeny tiny compared to those two. And you usually have different ones on the outside. This is called the Bohr model. We will be looking at this a bit more. But usually there's an electron floating around, and a proton and neutron are hanging out in the middle in a thing called a nucleus. Just like the nucleus of a cell. The center, the control center, the main stuff goes on there. So their respective charges, so A, B, C, so charges are, so a proton has a positive charge. An electron has a negative charge. And a neutron has a neutral charge, or no charge at all. And that's why they're kind of, think of a magnet. Opposites attract, these two are attracted to each other. That's why it's floating around there. You can kind of think of it like that. So it holds different things together. It's just like a magnet, positive and negative. So that is what's going on there. All right, the number of protons in one atom of an element determines the atom's identity. AKA what it is. So what type of element it is. So what it is. And the number of electrons determines the charge. So whether it's positive or negative, that's going to be the electron's job of the element. So the number of protons is going to tell you very directly what element it is. The atomic number tells you the number of protons in one atom of an element. So if you look at this, we've got gold right here is going to be our standard. We've got gold. So the atomic number right there, that is also how many protons there are. And you can see on here, well, hydrogen, we have 1, so that means there's 1, that's its atomic number, and how many protons are there. It's both. So the atomic number tells you the number of protons in one atom of an element. It also tells you the number of electrons in a neutral atom of that element. So if the atom is neutral, that means the same amount of electrons or protons are there, so you can assume that they're the same. And what do you mean neutral? There's all such new stuff. We can see all these pluses on there. These will tell you whether it's positive or neutral, or could be one or the other, so it can change a little bit. There's always a lot of change and variety in elements. The atomic number gives you the identity of an element as well as its location on the periodic table. So that's what I was just talking about. No two different elements will have the same atomic number. So gold and lead are going to have different atomic numbers. Always. That's what defines it. No two elements are going to have the same amount of protons. That's what makes one element different from another. The atomic mass atomic mass of an element is the average mass, average being, so it does change, of an element's naturally occurring atom or isotopes, taking into account the mass of each isotope. So atomic mass, if you look back to our gold example, is this thing right here, this number right here. That's how much it weighs. The atomic mass. They call them atomic right there. So 196.967. That's once again an average. So it's not always the same. So the atomic mass, so how do we find it? Of an element is the total number of protons and neutrons in the nucleus of the atom. So remember, those two things hang out in the nucleus, the center of the atom. So in order to calculate the number of neutrons, you must subtract the atomic number, aka how many protons there are, from the atomic mass. We're going to go into some examples. That'll tell you how many, on average, neutrons there are. How many average neutrons there are. All right, it's a lot of information. We're going quick, but you can look back and stop the video at any time. All right, number 7, give the symbol, the number of protons, atomic mass, and the number of neutrons in one atom of, and then we've got a bunch of different ones. So we're going to do 2 of these together. We're going to do lithium and iron together. So first we have to locate it, and locating it is a bit of a pain. There's no easy way to do it. We'll just put it on there until we find lithium. I know where it is. Oh, there we have lithium right there, so I'll zoom in on it. So we need to find out the protons. So number of protons is, the symbol is first, so the symbol is Li. Lithium is our friend. So symbol is Li, so make sure you write that. The number of protons, so number of protons, that is the same as the atomic number. So on this one is going to be 3. And just do it in order, so you don't need to worry about it. Atomic mass, the atomic mass is always below the name. Sometimes you're organized differently, but usually it's in a decimal because it's an average. So 6.941. 6.941, and then the number of neutrons. So to find the number of neutrons, it's not on here, but you take the atomic mass and you subtract the number of protons on there. So 6.941 take away 3 equals 3.941. So 3.941. All right, iron. Let's try iron. So we need to find out the symbol, the number of protons, which is the same as the atomic number, the atomic mass, and how many neutrons on average. That's why it's a funny number like that. So you're gonna find not all the elements make sense with their symbols. So like hydrogen, for example, is H. Awesome, that makes sense. Helium over there, He, makes sense, helium, He. But gold, Au, what the heck? What the hey? Well, that is quite often, it comes from Latin or Greek. And so lead is, iron is one of those. So it's kind of hard to find, but just go one by one and you will find it. So iron is right there actually, Fe. Ferrium, I think is the Latin name for it, that's why it's Fe. So it's kind of confusing sometimes. All right, so Fe we've got right there. So what is its symbol? Is Fe is iron? Let's write the symbol. Fe. What is the atomic number? 26. So that's how many protons there are. 2, 6. What is the atomic weight? 55.845. .845, and then we just subtract this from there to find that. So, oops, 55.845, take away 26. Good old-fashioned subtraction. That's a 4. We get 9. 29.845. So it's how many neutrons on average is 29.845. That's all we do. So you've got a few extra ones to do on your own. Oxygen, krypton, uranium, barium, and chlorine. Not chloride, but chlorine. Enjoy. Bye. Sorry about the long video as well.